Moles questions for IGCSE board. Here we will be solving the questions from the structured paper. So let us start with the first question. The question says, in a titration, 25 centimeter cube of 0.0800 moles per decimeter cube aqueous potassium hydroxide is neutralized by 20 centimeter cube of dilute sulfuric acid. And then the equation is given, which provide me the reaction between KOH and H2SO4. And the question is asking to calculate the concentration of H2SO4 in grams per decimeter cube using the following steps. Now, in this particular question, first of all, let me find out what is given already in the question. So, the given conditions are that I have the volume of KOH. From the unit, I can very easily identify that the volume of KOH is 25 centimeter. Centimeter cube or decimeter cube defines the unit of volume. Apart from that, I have the concentration of KOH, which is given as 0.0800 moles per decimeter cube. Again, we can always use the unit. Moles per decimeter cube refers to the unit of concentration. Now, the first part of the question says, calculate the number of moles of KOH used. So, here to calculate the number of moles of KOH, moles equals to concentration multiplied by volume. Now, concentration, we know it is given as 0.080 and the volume is given as 25 centimeter cube. Obviously, as concentration is decimeter cube, we have to convert it into decimeter cube, and for that I have to divide it by 1000, and in that case the answer will come as 0.002 moles. So this is my first part. Now coming to the second part of the question, determine the number of moles of H2SO4 which reacts with the KOH. Now once we got the moles of KOH, to find out the moles of the other component, we will use the ratio given in the balanced chemical equation. If you see the balanced chemical equation, here 2 moles of KOH reacts with 1 mole of H2SO4. That means the ratio between KOH and H2SO4 is 2:1, which says half amount of H2SO4 is required to react with KOH. So whatever number of moles of KOH are needed, half number of moles of H2SO4 will be needed. So moles of H2SO4 can be calculated as moles of KOH divided by 2. So moles of KOH we have already calculated, 0.002 divided by 2. Answer will be 0.001 moles. The third part of the question, calculate the concentration of H2SO4 in moles per decimeter cube. Concentration, again we will be using the same formula. Concentration is equals to moles upon volume, where volume should be in decimeter cube. We have the moles of H2SO4, we have just calculated 0.001 upon volume of H2SO4, which is already given in your question, that is 20 centimeter cube of dilute sulfuric acid. So we will be using this 20 centimeter cube. As it is in centimeter cube, we have to divide it by 1000 to change it into decimeter cube. And solving this, I will get the answer 0.05 moles per decimeter cube will be the concentration of H2SO4. Now coming to the fourth part of this question, calculate the concentration of H2SO4 in gram per decimeter. We have calculated the concentration in mole per decimeter cube. The fourth part says calculate the concentration in gram per decimeter. So whenever we have to calculate the concentration in gram decimeter cube, that can be calculated by concentration in moles per decimeter cube multiplied by the molar mass of the substance. So concentration in mole decimeter cube is 0.05 multiplied by molar mass of H2SO4, which is 98, and the answer will be 4.9 grams per decimeter cube. We got all the four answers over here. Coming to the second question, the equation of the decomposition of hydrogen peroxide is given. So this is the equation where hydrogen peroxide dissociate to gives you water and oxygen. 50 centimeter cube of a 0.200 mole decimeter cube solution of hydrogen peroxide is used. Calculate the mass of oxygen that is formed using the following step. Now the first step is calculate the number of moles of hydrogen peroxide. So for the first step, we will first write what is given over here. So from the question, I can say I have the volume of hydrogen peroxide, which is 50 centimeter cube, and I have the concentration of hydrogen peroxide, which is 0.200 moles per decimeter. Now the formula which I'm going to use over here is the same, concentration equals to moles by volume. Now as I have to calculate number of moles, so moles will be concentration multiplied by volume, and this volume is always in decimeter cube. Concentration is given as 0.00 multiplied by the volume 50 centimeter cube, as it is in centimeter cube. To change it into decimeter cube, I will be dividing it by 1000, and my answer will be 0.01 moles of H2O. The second step says determine the number of moles of oxygen produced. Again, as I have the moles of one component, to find out the mole of other component, I'll go to the balanced chemical equation and see the ratio. From here, the equation tells us that 2 moles of hydrogen peroxide decompose to give 1 mole of oxygen. That means the ratio is of 2:1. Whatever amount of hydrogen peroxide is present, half of that will be the amount of oxygen. So the number of moles of oxygen will be half of moles of hydrogen peroxide. So that will be half divided by moles of hydrogen peroxide we have calculated at 0.01. So the answer will be moles of oxygen will be 0.005 mole. Now coming to the third part of this question, calculate the mass of oxygen produced. Mass of oxygen. So here the formula used will be moles equals to mass upon molar mass, relative molar mass of the substance. So as I have to calculate mass, that will be moles multiplied by molar mass. I have the moles here. For oxygen 0.005, molar mass of oxygen O2 is 32, and the answer will be 0.16 gram. Coming to the third question. The question says the equation for the reaction is given. Zn plus H2SO4 gives you ZnSO4 and H2 gas. Now here 25 centimeter cube of 2 moles per decimeter cube H2SO4 is added in excess of 0. Calculate the volume of hydrogen produced at room temperature and pressure. The volume of 1 mole of any gas is 24 decimeter cube at RT. The first step asks me to calculate the number of moles of H2SO4. Again, using the same method, the values given for H2SO4 is the volume of H2SO4, which is equal to 25 centimeter cube, and the concentration of H2SO4 is given as 2 mole per decimeter. Now, if I have to calculate the moles, formula which I use, concentration equals to moles upon volume. So, moles will be concentration multiplied by volume. Your volume should always be in decimeter cube. Do remember this. So, concentration will be my 2 multiplied by volume 25. To convert it into decimeter cube, I have to divide it by 1000, and the concentration will be 0.05. Sorry, the number of moles will be 0.05. My first part. Coming to the second part of the question, deduce the number of moles of hydrogen produced. Now, as I got the moles of H2SO4, I'll go back to the balanced chemical equation and I'll see that what is the relation between the ratio of H2SO4 and H2. So that is 1:1. Whenever 1 mole of H2SO4 is consumed, I can see 1 mole of hydrogen is produced. So in that case, whatever is the number of moles of H2SO4, as the ratio is 1:1, moles of H2SO4 will be equal to moles of hydrogen produced. So that means here also the answer will be 0.05 moles. Then coming to the third part, they are asking you to calculate the volume of hydrogen at RT. Now, as we know that 1 mole of any gas at RTP has a volume 24 decimeter cube. So how much volume for 0.05 moles of gas? That will be 24 multiplied by 0.05, and your answer will be 1.2 decimeter.